In the 2013 film Gravity, George Clooney and Sandra Bullock are performing a spacewalk when a Russian anti-satellite missile hits a defunct satellite, causing a cloud of space debris to hit the shuttle, forcing them to evacuate and move to the ISS, which is also not in a very good condition, and everything is just going downhill from there. Today we're gonna be talking about all of that, or, the important parts. Space debris, Kessler Syndrome, anti-satellite missiles, and all that sweet stuff. I'm Homer, you're listening to Sci-in-the-Fi, the show where we talk about science through the lens of fiction, and then we come all the way around back to fiction to imbue some more science into it and get some fresh ideas instead of recycling the same things that we see the past 70 years. Because science has made progress, and I would like to see fiction do the same. Although I have to admit Gravity is actually a very good step in that direction. Let's jump right into it. So space debris is not only limited to satellites that have been destroyed and are now debris, but also satellites that are now inactive and are thus not controllable, and they might as well be a huge piece of rock. And they also include parts of payloads, like for example covers from cameras, because you need to protect the camera until it gets up there, and also tools that have been lost during EVAs, more than once. Humans are a clumsy race. In addition to that, some less expected space debris might be entire rockets, and of course their shrouds and fairings. Back in the day, we didn't know better, so we would just launch something, and the first stage might come down, or not, and the second stage would probably not come down, because why spend extra fuel when you're on such a tight budget already? Which we kind of still are, but we have gotten better at it. And of course there are things that are a bit more benign. We cannot completely get rid of space debris, because for example there's stuff like flakes of paint, which are shaken loose when you're relighting the engines or when you're separating the stages, and maybe they have also gotten eroded from the sunlight or intense heat. On top of that, there's also micrometeorites and just natural objects that get captured in Earth's orbit. Now, in a previous video, I asserted that space is a very, very big place, and in order to hit anything when going from point A to point B, you have to be actively trying. And since I know that you're a very loyal viewer and you watched that video, now you might be thinking, what are the odds? Well, I'm telling you anyway. Thing is, we get warnings quite frequently. Warnings in satellites are issued when you have a chance of about 1 in 10,000 of a collision. If it is above that, you get a warning and you start planning for maneuvers. You will get new warnings from JSPOC, and if the situation does not improve, then you will be executing that maneuver, burning up fuel, which means that you're shortening your mission lifetime because you've only got so much fuel. Now, the chances of a collision happening are quite low. This 1 in 10,000 is actually a slightly laxer requirement than the one used in commercial aircraft. But then when you start stacking up how many orbits are happening, that is about 14 to 17 per day for low Earth orbit spacecraft, which is the majority of them, times how many spacecraft are out there, it becomes more than just an eventuality. It actually has happened more than once. And because when you do have a collision, you will have more debris coming out, the chances of it happening again goes up every single time. Now, if these collisions are already happening, and every time there's a collision there's more debris, so it becomes more likely that we'll have another collision, you can extrapolate into its logical conclusion, which is what Donald J. Kepler did in 1978. Kessler suggested that you can get to a point where there is so much space debris out there that you can basically have inevitable collisions just about all the time. Nothing is safe. Space basically becomes unusable. He proposed this in 1978, and in 1982 the first conference on space debris was hosted by NASA, so people warmed up to this idea quite fast. 1 year later, the first workshop on space debris was hosted by ESA, and in 1993, a decade after that, ESA founded the Interagency Space Debris Coordination Committee, IADC. And in fact, the next year, in 1994, the United Nations Committee on the Peaceful Uses of Outer Space made space debris part of its regular agenda. Now, I'm saying all of this because I'm seeing a bit of rage bait lately about space debris and the responsible use of space and all that, and I will be touching on some of that. But this is not something that people are just ignoring, and it's not a calamity that's waiting to happen and no one's doing anything about it. We have been talking about this for 30, 40 years, if we're talking the UN 30, if we're talking ESA, NASA 40, and it's just not newsworthy, and I get why it's not newsworthy. These are basically long documents and regulations that are being published in gigantic long meetings, and No one wants to hear about that stuff. But if you turn it into rage bait content, suddenly it goes viral or something. So, rest assured, we know this is not news to us. Okay, let's step away from long conferences and talk about actual collisions. So, there are 6 confirmed fragmentations from collisions between artificial objects and satellites. But there's also 65 anomalous fragmentations, which are suspected to be space debris collisions. That is not to say that everything that fragments we believe might be space debris. These are 6 and 65 out of a number of fragmentation events, many others already attributed to other causes. These are just the ones that we believe are from collisions. A couple interesting ones are the 1996 Ceres satellite, if I'm pronouncing it correctly. It should be French, because it is from the French government, which was hit by a fragment of an Ariane rocket, the same kind of vehicle that put it in orbit. Over many orbits they had come close, and eventually one of them got hit. Now, the whole satellite was not destroyed, it was just severed from the boom extension that it had, which was for gravity gradient stabilization. It's an interesting method where you can just attach a mass to a boom, poke it out, and it'll keep you pointing toward the Earth. That's for another video. But the big one is the Iridium-Cosmos collision of 2009. In that one, an Iridium satellite hit the dead Cosmos satellite, so an American and a Russian one, and that produced 2,375 fragments. Now see if you can spot that collision in the charts later on, because it made a difference. You can see the space debris count go up. Recently, however, we have seen impact beyond space. It was recently highlighted how airlines had to evacuate a zone during a spaceship re-entry, but this is something that also happens for space debris re-entering every now and again, and they say it's happening more and more often. Now, the idea of space debris falling on people's heads is also not new. A rule of thumb is that if something is above 1 ton, it can generally be expected to survive re-entry. And for that reason, here's a fun fact, we deorbit in a couple of zones of the ocean far away from settlements, and according to H.P. Lovecraft, the spot in the ocean that is furthest away from all human settlements is where dead Cthulhu lies waiting. So yeah, we're dropping space debris on Cthulhu's head. I assume that's why he's still unconscious. Jokes aside, these satellite graveyards have been chosen very specifically for minimal impact, and we have of course studied ahead of time whether or not there is significant contamination and pollution, and frankly, this is really not a problem. Like, space is not at the point where the scale of its activities can contribute to pollution to any significant extent. At least, compared to stuff like cars that most people are driving every single day and airplanes that are flying every 5 minutes from major airports and traveling for hours at very high speeds. Editing Homer here. It seems it's not entirely clean, but it's also not super well studied, at least over time. There do seem to be 2 factors that we are a little bit concerned about. One is black carbon deposits from more classic rocket fuels, which are carbon-based, and the other one is aluminum oxide deposits in the upper atmosphere from solid rocket motors. These do seem to have short-term effects, and the greenhouse gases are actually not showing up that much, so water and carbon dioxide. This is something that needs to be studied further, and is something that should probably get either regulated or at least monitored on a longer term so that we can see if this is something we should be concerned about, since the space industry is still expanding more and more every year. Oh, also a story from relatively recent history. There was that Chinese booster that went into space, and it did in fact deorbit. I guess that's a step forward from leaving our boosters flying around space. Except it was a completely uncontrolled deorbit, and there was a small chance that it would land in New York City. Which definitely made for an interesting 2-3 days until we waited for it to actually re-enter. Now, before I get back to gravity and the whole fiction meets reality aspect of things, I need to talk about one more thing in the whole space debris and orbits thing, and that is orbital decay. We say that above a certain altitude, you're in space. You're no longer inside the atmosphere. There is no air anymore. That is not strictly true. It might be practical to say, but you still got some air up there. And to illustrate just how this line is not very clear, Europe and the United States have different standards for what is considered space, with Europe saying 100 kilometers and the United States saying 80 kilometers. Now, even way above that, 500, 800 kilometers above the surface of the Earth, you still have particles, single atoms of oxygen and whatnot that are just flying out there. They have gone a little bit outside the atmosphere, and they're gonna fall back down. But in the meantime, these things are gonna be hit by spacecraft. One-on-one, these collisions are not gonna do anything, but over time, they start accumulating and the spacecraft is losing speed. And when things in orbit are going slower, they drop into a lower orbit. It's not like electrons, it's a more continuous process, but they will be losing altitude. Now, eventually, as they lose altitude, they will find themselves encountering more such particles, so they're going to be slowing even faster and losing altitude even faster, and eventually they're going to be hitting the edges of the atmosphere, at which point they are basically under air drag and will be deorbiting soon. Now, this is important to keep in mind for two reasons. First of all, any debris that is passing close to the Earth's atmosphere is going to be decaying relatively fast. It might still be months, but at least it's not going to be there forever. Second, if you have debris produced close to the Earth's atmosphere, then by definition it's going to be passing close to the Earth's atmosphere because it will have to pass from the same point again, and thus it will not be staying there for long. So if you're going to have debris produced, you better do it at a low altitude. Now, having talked a bit about orbital decay, we can go back to the intersection of fiction with reality and talk about anti-satellite weapons, such as the one depicted in Gravity. These are a real thing. Between 1968 and 71, we had the first 8 tests by the Soviet Union. Then they slowed down a little bit and did 4 more until 1985. The 4th was actually USA's first test. And after that, they slowed down quite a bit because we kind of knew that, okay, 1, we can do this, and 2, it's not nice when we do it. So there were only 4 more between 85 and 2007. 2007, however, broke the streak with quite a bang. China tested its first anti-satellite weapon, and that produced more than 3,000 pieces of tracked debris. And 9 years later, over 2,800 of those pieces were still up there being tracked. This is long-lasting, and it's a lot of debris, and this is exactly the kind of thing we do not need. This is the kind of events that lead toward Kessler Syndrome. Since then, things stayed a little calm for the next 15-ish years. 2008, we had Operation Burnt Frost. That was a United States anti-satellite launch from a Ticonderoga-class cruiser, and it was targeting the controlled re-entry of a satellite with about 1,000 kilograms of hydrazine, a highly toxic fuel, which, if it actually reached the ground, would have contaminated a very big and potentially populated area of land or sea. Now, given that this satellite was doing an uncontrolled re-entry, it was close to the atmosphere, and most of the debris orbited really fast. 2 pieces did last longer, but that was not super bad. However, the politics were very interesting due to the timing. Just a few months ago, the US had decried any use of weapons in space. So this was a very interesting backflip over there. However, since then, they have not done any other tests. The US, that is. Of course, others did. In 2019, India did a relatively responsible test. Most of the debris then decayed within weeks or months, but the last one did last until 2022. But still, I'll say it's not horrible. And in 2021, Gravity basically became almost a documentary. In 2021, Russia hit the Cosmos 1408 spacecraft, and it caused a bit of a panic on the ISS. Just like with Gravity, a debris cloud started going around the Earth, and it passed multiple times near the space station. The astronauts scrambled to get into the Soyuz capsule just in case, so they can evacuate quickly, and no one was happy about that. Now, some nuance is required when we talk about anti-satellite tests, because indeed some of them are done in low altitude or with re-entering objects, and those will generally produce debris that will decay really fast. Although now that lower altitudes are getting populated, this is again getting very dangerous. And the thing is that even if it is at low altitude, the orbit can be quite elliptical, so it can be passing from a low altitude and going into a higher one, and at that point it can cause collisions in a higher altitude, and the debris from those collisions are not going to be decaying fast, not to mention we've already got a multiplication, so that is not good. So, yes, some nuance is required. Operation Burnt Frost may have been justified and may have been done in a way that did not cause problems. On the other hand, things like Cosmos 1408 or the 2007 test produced a lot of problems. So, generally, bad idea. So we've looked at what is up there and how it ended up there and like why it's important that we know that it is up there. But how much of it is up there is the next question. And the answer is probably more than you might think. There are 54,000 objects larger than 10 centimeters, including about 9,300 active payloads, active satellites that we can control, that we are tracking very narrowly. For those, we usually have about day-old information about their position and velocity. They're big enough that basically almost all instruments that we use to track space debris can pick them up. But in addition to those 54,000 objects larger than 10 centimeters, which is definitely very lethal, we have 1.2 million space debris between 1 centimeter and 10 centimeters. And while that is considerably smaller, you will know by this point that this is still very dangerous for spacecraft. On top of those 1.2 million pieces between 1 and 10 centimeters, there's 140 million pieces estimated between 1 millimeter and 1 centimeter. This is still a size that, while small, can impact individual devices on the spacecraft and is still capable of producing other small fragments. And you may have noticed 140 million is a pretty big number. Can we do anything about it? So let's look at the simplest solution. Can you shield your spacecraft from debris? And the answer is yes, kind of. First of all, just like with the armor of a tank, if you shoot something heavy enough and fast enough at anything, it will eventually go through. So of course we're not talking about absorbing the impact of a 10 centimeter piece of aluminum, we're talking about smaller debris, maybe up to 1 centimeter. So your first instinct when dealing with things coming at high velocity might be slap some armor on it. And this 10 centimeter piece of aluminum could probably do the trick. Thing is, it's just not enough. When you have a piece as little as 1 centimeter of a material as light as aluminum, like this ball over here, impacting at a velocity of kilometers per second, which is what you're dealing with at orbit, the energies involved make the molecular bonds basically irrelevant. This thing turns into a liquid, and as you see, it basically splashes. Now, this is already very unhealthy for whatever is being hit, but there's more. The obvious thing is that this is quite heavy, and you have to lift it into orbit, which costs fuel, which is fuel that you could use for something else, and it takes up a lot of space, which, again, you could use for something else. But the main thing is that at the bottom side, you see that this part has detached. And this is basically the shock wave reflecting off the bottom side and traveling back in and pushing it off. As if this wasn't bad enough, your main problem is that whatever was on the backside over here, like paint or surface imperfections, will have flown off and basically turned it into a shotgun. So you're basically not safe even with a significant mass between you and the piece of debris. Oh, and side note, this is not the original one that hit it. The original one, maybe a little bit is left over here, but it is otherwise evaporated. There is, however, another form of shield which is a lot more effective and a lot lighter. This is called a Whipple shield. It consists of multiple layers, starting and ending with an aluminum sheet, and in between a few layers of Kevlar. The way it works is the impactor hits the outer aluminum sheet and turns into vapor. This vapor is then hitting successively the Kevlar layers in between, which spread out the force and can start absorbing it. And you still usually get vaporized material hitting the back sheet, but at that point it has gone through multiple layers, it has lost enough energy that the rear sheet is actually going to stop it completely. This is very light compared to just raw aluminum, and it does have the downside of taking up quite a bit of space because you need to have some space to let the vapor expand. However, if you're only shielding the critical parts, the ones that you cannot afford to have damaged, it's actually a very effective way to protect your spacecraft. Now, I do have an honorable mention in the shield category, which is the honeycomb panel. This is more actually of a structural component. These are the panels on which we bolt on all the other things. But they do kind of act like a mini Whipple shield in the sense that they do have two layers and they have the whole like hexagonal structure in between, So when something impacts, it will generally vaporize on the outer layer, and it has a chance to slow down, especially if it is at an angle and it goes through a few of those honeycomb cells, and maybe get blocked on the inner layer. But again, this is more of a structural thing. It's more interesting that this is extremely lightweight and it is very rigid as well, so it can actually hold everything even though it is literally paper thin sometimes. And of course there are other kinds of shields which are more conceptual. Mikio Kaku's book Physics of the Impossible discusses how you could have potentially plasma shields or nanocarbon shields, but this is more in the realm of the science fiction. And it's something I would like to talk about at some point, but this video is already getting long enough that I'm considering breaking it up in multiple parts. Now, of course, shields are a mitigating factor. They will protect what we put up there from being hit by what is already up there. But they're not really doing much for the future. So the natural question is, are we doing anything to make sure that this doesn't get out of hand in the future? And the answer is, thankfully, yes. There is a coordinated effort on a global level. The Interagency Debris Committee published in 2002 the Space Debris Mitigation Guidelines. ESA has been publishing the Space Environment Report since 2017, keeping very close track of the evolution of space debris and what is being done about them. And the UN Committee on the Peaceful Uses of Outer Space published in 2019 its own guidelines. These guidelines generally boil down to one thing: the IADC's rule of 25 years post-op, this thing has to have deorbited naturally. Now, the majority of payloads under 1,000 kilograms will naturally adhere to this rule, but we're also looking to do controlled re-entries, bring them back into the atmosphere on purpose. And the number of controlled re-entries for rockets, for example, has gone up from 10 to 65% of rockets in the last decade. And having reusable rockets really helps with this, because then you actually have a reason to bring it back down, which is to reuse it. 2024 alone saw 1,200 re-entries. In fact, we are planning ahead to the point where we are looking beyond Earth. There is a lot of push for lunar activity and exploitation of the lunar environment, and we are hoping to see in the next few years permanent bases on the moon. And this will require infrastructure around the moon, which will in turn have satellites that eventually have to be switched off and disposed of in a safe way. Otherwise, we will have the same problems around the moon. And there are already some guidelines being formed about which satellites have to be deorbited onto the moon, broken up right on its surface, which ones should be going into a graveyard orbit around the moon, and perhaps even some in even higher orbits just get shot out into a solar orbit, which we believe is going to be centuries before that one starts getting clogged up. And this extends beyond Earth and the Moon. This is also extending to Mars, where we already have a handful of satellites flying around it. It is a very small number, we don't really have to worry about it today, but we are looking ahead into the future because we know that the future is not quite as far as we thought, and planning ahead will save us future headaches. And while preventing further debris from getting up there and making sure that everything that we put up there comes down is nice and dandy, we should also be looking at cleaning up what is already up there. And we are. There's two categories over here. There's things that are supposed to take down spacecraft that are inactive and larger pieces of debris, and things that are supposed to take out a lot of the smaller pieces, which are way, way more and basically more dangerous because we can't track them as well. Demonstrators have been flown for capturing satellites using claws, harpoons, nets, and magnets, and the harpoons were actually a bit too violent, so that might not be making a comeback. But each of these was shown to work. Companies like Sari Satellite Technologies Limited, Astroscale, and CleanSpace are prototyping spacecraft that are demonstrating these capabilities, while the ESA with the ClearSpace 1 and CAT missions is also providing functional demonstrations, with ClearSpace 1 intending to take down a non-functional satellite. However, the pieces that are larger than 10 centimeters are 56,000, whereas the pieces that are between 1 and 10 centimeters, as mentioned, are over 1 million. These are harder to deal with because tracking them is very hard, and it's very hard to catch them, but there are a few ideas. The one I find the most plausible is using lasers to modify their trajectory, because light does exert pressure. But I was also asked during a convention if just putting a gigantic broom up there and sweeping them up is an option. And it kind of is. I don't know anyone actually working on this, but it has been proposed that we could use gigantic sheets of aerogel or some kind of metallic foam, which would be very light and very big and easy to track, and would probably impact a lot of these small things, and thus gather them up and reduce their number, and then naturally let it decay into Earth's atmosphere, bringing down hopefully thousands of pieces at a time. Now, I have mentioned natural decay a couple of times during this video, and this does affect space debris as well. It does naturally fall out. As we saw in the anti-satellite tests, most of the debris produced from the ones that were very low, close to the atmosphere, went down on its own after not that long. However, the higher you get, as you start getting to the level of the ISS or a little bit higher, the effects of the atmosphere of these trace gases start getting smaller and smaller, and a lot of the debris is on highly elliptical orbits, meaning that only part of them is spent close to the atmosphere. And that part is going to be the briefer one, because things move faster when they're near the planet and slower when they're far away. I did, however, want to point out one very interesting fact that I found while researching, which is that solar activity affects this phenomenon. When the sun has very strong activity, it tends to puff up the atmosphere, and thus extending a bit the range of this higher drag region. And this is something that I did know because, well, when I was flying ASAT 1, we were monitoring solar activity and hoping that it would ease down so we could get a few more weeks or months of lifetime before it decayed. But apparently this has also been mentioned as a factor reducing the number of maneuvers that commercial missions of entire fleets have had to do, where effects on small things start becoming statistically significant because there are now multiple satellites, hundreds or even thousands, flying in sync. However, if you look at this graph, natural decay on its own will definitely not be sufficient. In the red line, you can see what happens if we keep on launching missions at a rate that is increasing based on our experience up to today. And the blue line is what happens if we don't launch anything new and we just let things go the way they go. And you see that slow but steady, it does show a constant increase of debris. So when all is said and done, we have to estimate how likely it is that we'll get Kessler Syndrome. And while the science behind this is a lot of statistics and math and physics, the results are kind of consistent. There is an orbital sustainability threshold, which we are not meeting. If we launch nothing else, we should be fine. But that is not likely to happen. We are consistently about 3 to 4 times above that safety threshold in our estimate. However, I want to stress out that right now, it's something that could happen, but it's not something that is extremely likely to happen. We are not at the point where we are stopping launches or limiting launches because of that. No one is saying we should limit the use of space. And commercial space is something that has been drawing a lot of attention, especially with SpaceX that has literally thousands of Starlink satellites and recently announced that they're considering doing a fleet of AI processing satellites in low Earth orbit that's going to be way bigger than this. And we do indeed see that the majority of traffic is actually commercial satellites nowadays. However, in spite of the fear-mongering that's going around and all the complaints about SpaceX being irresponsible, the real picture is not really there. We have to separate the elephant in the room, Elon Musk, from the company that is being run by engineers and specialists, and yes, guided by him, but not operated by him. SpaceX did 25,000 maneuvers between December 2022 and May 2023. This is multiple orders of magnitude bigger than any agency is doing. And in the next 6 months, by mid-2024, they did 50,000 maneuvers. They doubled it. And in fact, they're not using the 1 in 10,000 threshold that agencies are using. They're using 1 in a million threshold. So they're being extra careful. Now, this is according to an article on SpaceXstock.com, which I find reasonably convincing. And the same article says that 90% of these maneuvers are for space debris. And the other 10 should be for satellites, but these are satellites flying at 200 kilometers, which is mostly just SpaceX satellites. New Scientist published a new estimate of 300,000 in 2025. A link to the article in the description. This is an insane amount of maneuvers being done and at the very, very low threshold of probability of collision, so irresponsible is not the right word to use over here. They seem to be extremely cautious, and the fact that they're doing all of these maneuvers on an almost automated basis is actually very convenient for other agencies. Colleagues have reported that while they used to be getting maybe one warning every 2-3 months, now they're getting basically weekly warnings. But we still rarely have to do maneuvers. We do maneuvers, but we rarely have to do maneuvers because usually SpaceX is the one doing them if it is a SpaceX satellite. So this is not to praise Elon or anything like that. This is about the company specifically and about commercial. And we have to look beyond SpaceX because OneWeb and Amazon are also looking to deploy their own fleets. And it's hard to tell companies to not operate in the way they want to operate if we are working toward the ideal of space for everyone, space that is open and accessible. And we also need the companies to make space more efficient. SpaceX has reduced launch costs by a significant amount because they're funding their own research and they're doing things that you cannot just spend public money on just like that. You cannot have 17 failed launches of SLS because then you come under scrutiny, which means you have to take way more time preparing before you can do the expensive thing of launching the satellite. Anyway, my point with all of this is you cannot really stop commercial from operating when it is showing that it can operate responsibly. I am more concerned about startups that want to deploy fleets and then they might close overnight and leave these satellites with no one controlling them. Or perhaps they do not test enough and then they just have out-of-control satellites due to a software bug. Anyway, end of this segment. A rare example of active debris removal in popular culture is the anime Planetes. It is hailed as one of the most hard sci-fi anime out there, or in fact media, adhering to the laws of orbital mechanics and general science as we know it. And it centers around a crew dedicated to debris removal to maintain the orbit of Earth relatively safe. If this has piqued your interest in any way, I can strongly recommend this anime, as the creators actually studied the whole thing, and they actually got in contact with JAXA scientists to advise on it. And while I haven't finished the anime yet, what I have seen is quite impressive. Another subject I found really interesting is the way we track space debris, but that's a very broad thing. We use anything from radars of various types, in fact, telescopes, starting with the Baker-Nunn camera, lasers with which we gather statistical data based on how often they get interrupted, and we do them both from ground-based platforms and space-based. Usually spacecraft that have some other primary purpose but can also be used for space debris are providing supplementary data. And in addition to these, we had the long-duration exposure facility and the Mirror Environmental Effects platform, which were just left in space for a prolonged period of multiple months, just to see what damage they take from the space environment. Subscribe to the channel for more on this. Now, before we wrap up, I want to get back into the Fi side of Sci-in-the-Fi. The emergency parts, like the ASAT hit, was basically gravity, and that almost became a documentary. The cleanup part is also covered by Planetes. In The Expanse, we also see space debris weaponized, micrometeorites being used against spacecraft like a gigantic, very powerful shotgun. While this is basically the grand sum of what I have from television and cinema, it is worth noting that Kessler Syndrome could also be weaponized, and this is something that exists in some books. But more than anything, a very overlooked side of space exploration is the politics. Both in real life, space has played a big part in politics, and was one of the first places where the Soviet Union and the United States collaborated, but also in fiction, it can be a highly political issue. And I have to say, space debris, being such a clear-cut but complex issue, is probably excellent fodder for a good political thriller or a driver behind other narratives, more than something that can be directly addressed. But just as the environment is often used as an opposing force for an adventure, the space environment could also be the background for many more adventures out there. Finally, I have some honorable mentions. WALL-E does a slightly comedic portrayal of space debris, but frankly, it is very much to the point. It portrays humans disrespecting their environment and being careless. Deadly Litter by James White seems to be the first story written with space debris at its center, and it dates back to 1964. And Professor Stanway from the University of Warwick has written an excellent article that summarizes a lot of depictions of space debris in literature, which, if this has been interesting to you, I definitely recommend you read. Link in the description. Now, one final thought. While I was doing the recording for this video, a friend from school shared another video of some guy on Instagram that was talking about space debris and SpaceX wanting to launch like millions of satellites into low Earth orbit and how that would definitely cause Kessler Syndrome. And I was very frustrated. I'm normally super happy when anyone talks about space and space exploration, but I'm really angry when people are trying to exploit that and do misinformation. Yes, space debris is a problem that is getting bigger and bigger, but unlike what that video claimed, we do not have daily collisions or all the time, as it said, collisions with satellites. That is a yearly occurrence, and it is something that we should pay attention to, but just like with the climate crisis, we are not yet at the point where things are a complete disaster. And just like with the climate crisis, that does not mean that we can just keep on going as we are. We have to improve, we have to do better, we have to be mindful in order to have a future, but we're not doomed. Closing that rant, maybe I do a reaction video to that one and just talk point to point what is going on, but I had to say it. Anyway, I hope you learned something interesting. I hope that you were inspired to do a bit more digging. A lot of other talented people on YouTube that have spoken in a lot more detail about different aspects of this, and I do fully intend to do follow-up videos on this, just because I found out so many things while researching this topic, there is just so much to say. I hope this also gave you some kind of inspiration, can now incorporate some more elements of reality into their fiction. As I have said before, science fiction seems to be recycling the same concept since the 1950s, and science has just expanded so much more, we're just missing out on more opportunities for storytelling. And that is sort of the launchpad for this series of videos, learning science through fiction and enhancing fiction with more science. Hope you have a nice day, and I hope to see you in the next one. Homer out.